going to continue our study of statistics by looking more closely at a normal distribution or a normal curve. I am recommending that you do the reading of the 12.5 section and watch the video that's tied to your electronic textbook and then come back to this video. In this video, I'm going to be going through some examples, but not doing as much work with explaining what a normal curve is or where it comes from and when we see it applied, etc. Simply because I felt like the time was best spent working through some of the examples and helping you see some shortcuts and some ways to process the examples. It is important to start with that you understand the empirical rule, and the empirical rule for a normal distribution gives us these percentages as estimates that approximately 68% of the data that is on a normal distribution falls within or between this one standard deviation below and above the mean. 95%, approximately 95% of the data falls within 2 standard deviations, and approximately 99.7% of the data falls within 3 standard deviations of the mean. So this is a starting point, is understanding or recognizing these 3 approximations as the empirical rule. And if you haven't already done the Blackboard activity part 1 for normal distribution, I'd recommend that you do that activity first, because that activity practices applying the empirical rule. But moving on to some other examples that go beyond this empirical rule, and again, the key is the 68, 95, 99.7 as the approximation of how much of the data would lie within 1 standard deviation of the mean. Let's look at a way that we can use that to estimate the answers to number 23, 24, and 25. Well, for 23 and 24, it's not an estimation. It will be a precise answer, because when we put our mean in, because the mean, median, and mode are all equivalent in a normal distribution, what we know is that 50% of all the data lies below and 50% of the data lies above the mean. So I can answer question 23 and 24 with 50%. So you could say 0.5. Most of the time we see these to 4 decimal places. 0.5 is sufficient, but to keep it lined up with the other responses, you might say 0.5000. So we're going to always go to 4 decimal places, and that's the answer to both 23 or 24, or we could say 50%. The number from the table is going to give us 0.5000. And then when we get to a question like number 25, between 1 standard deviation below the mean and 2 standard deviations above the mean, we could do an approximation, an estimate to start with. So here's our mean, and if we're looking for 1 standard deviation below and 2 standard deviations above, then what we're looking at is this area, and we're trying to use the empirical rule to get an estimate of what percent of the area under this curve, under this distribution, under this blue curve, what percent lies in this region. Well, we know that we've got in this space here, we know that we've got 68% from our empirical rule. So what we need to add to that is this segment off to the right. If we went 2 standard deviations out, we would know that this entire space The area under that curve was 95%. And if I subtract the 68%, so in other words, I'd be subtracting this part. Let me try another color. I'd be subtracting this gray area in the middle. That'd leave us 27%. So I know that the two sides, so if I had both of the pink and the black, these two black pieces, that total is 27. But my pink side, what I'm looking for is only one of those. So the next calculation is to find 1/2 of that 27%, because the 1/2 of the 27% were 13.5% is going to represent just that piece. So let me so that this purple part is 13.5. So I can see that all together, if I'm looking for this gray shaded area, the gray that's not purple also was 68. And then that purple part is 13.5. So it looks like this is all together 81.5%. Now this is just an estimate. This question asks us to use the table. So let's now look at using the table and see how close that approximation using the empirical rule comes. Let me show you how to use the table, so the chart, to get even a more precise response. If we're going for 1 standard deviation below, I'm going to start by sketching this. So I always start with my mean. 1 standard deviation below up to 2 standard deviations above. So one more time, I'll highlight this, or shade in, that this is what we're looking for. Then I could use this chart to find two things. What I'm going to do on the chart, and I know this might seem a little different just when you start, but what I'm going to do with the first thing I'm going to do is find this area. Let me highlight the area I'm going to find. The first thing I'm going to do is find all of this area to the left, everything to the left of 2 standard deviations to the right of the mean. I'm going to start with that. And then the next thing I'll do after that, I'm going to find everything to the left of 1 standard deviation to the left. So that would be this. And do you see that if I found this area in the top chart and subtract this piece here, the area in chart like sketch number 2, I would be left with this purple pink area that I'm going for. So let's try that with the chart. We're going to first find the percentage of the data that falls to the left of 2 standard deviations to the right. So that is going to be want 2 standard deviations. I'm sorry, you can't, because there's this little icon here, but if you can trust me that this is the 2. And we want 2.0. Oh, there, now we can see it. So 2.0, the percent is 0.9772 from our chart. Or in other words, 97.72%. And remember, what we wanted to do was subtract from that. We want to subtract from that the percent of the data that's at 1 standard deviation to the left. So that's going to be the other chart. Let me move this one out of the way. And we'll pull this one in. 1 standard deviation to the left is going to be represented with a -1. When I go 1 standard deviation to the left of the mean, now I've got a negative number. So it's to the left is going to be -1 on this chart. So -1 on the chart you can see is 0.1587. So let me get this chart out of the way and go over one more time why we're using those numbers. One more time, what our chart told us, these green number charts here, the top and bottom. And let me actually move them both down here so they're oh, sorry, that's not a great place to move it. Trying to move it out of the space. There we go. These 2 green charts in the bottom right and left corners, what they're doing for us is saying that 97 and 0.72% of the data is somewhere 2 standard deviations to the right of the mean or lower. So all of this area is 97.72%. And then we used from the chart when we did a -1, that chart's what that value on the chart, we got 15.87% on the chart. What that value, that 15.87% is telling us is that 15.87% of the data falls in this area. So that on our problem is this stripe over here. So what we were going to do is subtract those from each other, and when we do that we'd get 0.8185 or 81.85%, which is very close to that approximation that we got just applying the empirical rule. If we go back, 81.85, our estimate was 81.5, very close to our 81.85, which is a little closer approximation. That's the first example. We're going to do a few more. So if you feel a little bit lost now, hang on, keep going, do your best to understand, but we'll keep going and hopefully get better and better at doing this. So those were standard deviations that were a whole standard deviation, a whole number, 1 or 2 or even 3 we could use. What we need to do when we get a standard deviation that's not a whole number, for example 1.30 or 1.70, is understand what that means. Here's our mean, and here's our 1 standard deviation. Here's 2 standard deviations above the mean. That 1.30 is going to fall somewhere between the 1 and 2. And the 1.7 also is going to fall somewhere in between them. So we've got our 1.30 and our 1.70 are somewhere between the 1 and the 2. And what this question is asking us to do is find this area. Well, we can't do an approximation with the empirical rule because we don't have a whole number standard deviation, but we can certainly use the chart. And when I go to the chart to find this, I'm using a z-score. And so the z-scores are the 1.3 and the 1.7. That z-score, or standard score, determines how far in terms of standard deviation. So how many standard deviations are we away from the mean? For example, a data value that has a z-score of 1.5 indicates that the data value is 1.5 standard deviations above the mean. Now again, a negative z-score means that we're to the left of the mean or below the mean. If you wanted to calculate the answer for number 26, we could use the chart and find the 1.30 value, 1.30, and 1.7, and subtract those. So 95.54% or 0.9554 is the value, the area that's to the left of 1.7. Let me draw these in here. We're looking for the space between these. So the 95.54 is this area. And then what we want to subtract from that is the 0.9032. That's this area with the red stripes. And that's going to leave us the piece that we're looking for. So when I do this subtraction, I'm going to get 0.9554 minus 0.9032. I'm going to get 0.0522. So between 1.3 and 1.7 standard deviations above the mean is 0.0522. Let's try just a few more examples. Question number 27 asks us to find the probability or the area to the left of z equals 1.62. I am every single time going to start with a sketch so that I fully understand, I can fully see what I'm looking for. So here we are to the left of 1.62. If you enlarge the chart, you can see that this chart is giving us the area that's to the left of z. So if we're going to look for z equals 1.62, here's 1.6. So 0.2 is this number, this 9474. So 0.9474. Or 94.74% of the data lies to the left of 1.62 standard deviations to the right of the mean. You know, this picture, this sketch is helpful because as I look at the sketch, I can see that this 94.74 is a reasonable answer for that area that I have, for this area that I have shaded. Now I'm going to stop the video here and encourage you to practice these types of examples a little bit more. And the example we just did is this number 27. And then the next video we'll pick up with a few more examples that take us a little further in this practice. But this is a great start.